Eggplant AI is an exciting new product we've created that's all about the automatic generation of test cases and optimizing those test cases to maximize coverage and find defects, which is what testing is all about. We're very excited about this new product. We think it's a real game changer in terms of how people are going to go about testing, the productivity and effectiveness of testing, and hopefully you'll see how it can fit in with what you do. Since it's a new product and quite a different product, I'm going to start with a few slides to explain the original motivation for the product and the fundamental approach so you understand where we're coming from, what it's all about, and then we'll get into the demonstration. Now, today, as you guys know, there's lots of challenges facing test teams, and I've highlighted what we consider to be some of the key ones here on this slide. Just going around from the top, user satisfaction is low. 80% of downloaded apps are deleted within the first day, and 96% are deleted within the first month. Most teams are fighting a continual stream of post-release issues in terms of functionality, performance and usability, as well as low user adoption. Teams are also struggling to keep up with the pace of continuous delivery and DevOps. 89% of teams say they're struggling to keep up, and they have non-scalable costs that make it difficult to meet the needs of DevOps, technology diversification, fragmentation, and test coverage. And while the need for automation is increasing to address the productivity and UX gaps, traditional test automation can reach less and less of the application. 56% of teams say traditional test automation can't reach a significant proportion of their user journeys. So we have a user experience gap, a productivity gap, and an automation gap. We also have a confidence and predictability gap and a visibility gap that I'm not going to go into here. Now, we believe that teams are struggling because of fundamental flaws in their current approaches to testing. These approaches were created 10 to 15 years ago, and since then, the technology world has just completely changed. Digital experience, consumerization, DevOps, the Internet of Things, these have all changed how software products are architected, how they're produced, what they do, who the users are, and user expectations. But teams are still trying to use those same old test approaches, and they won't work. So our aim is to deliver a new approach to testing, which we call digital automation intelligence. And it's all about addressing these gaps. Now, I'm not going to go into detail, but very quickly, we need to test from the user perspective. It's the only way to test the real user experience. We need to test all aspects of the digital experience: functionality, performance, usability, security. We need to expand automation beyond test execution using AI, machine learning, and analytics. And obviously, that's going to be a big focus here in the demonstration. That's what Eggplant AI is all about. We need to report quality in terms of the user using predictive analytics, and we need to have a coherent approach to monitoring and testing. And as I say, Eggplant AI is really all about that middle one, expanding automation beyond test execution using AI, machine learning, and analytics. And that's really the original motivation for the product, this realization that although everyone talks about test automation today, I mean, I've already said it several times here, if we look at the entire test process, the reality is that we've only automated one part of testing, and that's test execution. There's still a huge amount of manual effort in terms of defining test cases, defining test runs, and so on. And the big advances in terms of the productivity and the time to market of testing and the coverage of user journeys, they're not going to come through sort of micro optimizations of how we automate test execution. They're going to come through expanding automation beyond test execution to the rest of the testing process. And that's exactly what Eggplant AI is all about. It automates the creation of test cases from a model of the application, and it uses AI and machine learning to optimize those test cases in terms of coverage and finding defects. Because even for a simple application, there are literally billions of user journeys. We can't execute them all. We need to be intelligent about selecting which ones will give us the right coverage and find the most defects. So coming back to those challenges I listed on my first slide, Eggplant AI is all about addressing that productivity gap by automating the creation of test cases, and it's addressing the user experience gap by massively increasing the user journey coverage that you can achieve. So let's go to the demonstration now. So I'm going to go to the Eggplant AI server, I'm going to log in. And I'm going to bring up my model here of the Amazon shopping application. The Amazon shopping application obviously is a very familiar application to most people, so I find it's a good basis for the demonstration. So here we have on the screen, so here we have on the screen a model of that Amazon shopping application. And let me just take you through the key elements of the model. So the most obvious thing are these big blue boxes, and these blue boxes represent screens. So we've got the home screen, across the top we've got the login screen, the My Account screen, the My Order screen. Down the bottom we have search results, so once I've done a search, get a set of results, that's the new screen. I click on one of those and I get the item details, and then I go through the checkout screen. So these big blue boxes are screens. Within screens I then have the different actions you can do on that screen. So you've got verify recommendations on the home screen, go to My Account, go to My Orders, search by department, and search. Some of these actions, like search, lead to a transition to a new screen. That's why they've got this connection from search to the search results screen. Others, such as view recommendations, don't. When you've executed the action, you stay on the same screen, and then you need to perform another action on that screen. Now, it's important to note that these are conceptual actions. These are how a user would describe how they use the application. They're not tied to specific technical elements of the user interface. They're not click this button, type this letter, move the focus. They're really how a user would describe using the application. And this is really important because we really want to relate this directly back to user behavior. We want to relate it back to the analytics we're getting from the user to create that feedback loop. It's also important to note that this is not a flowchart. So we've got actions, we've got transitions between actions, so people start thinking in terms of flowcharts, but it's definitely not. And the key example here is the login screen. If we had a flowchart, what we'd say here is you enter the username, then you enter the password, and then you enter the login. But that's not what we're doing. What we say is on the login screen, there's 3 actions a user can perform. And they can do these actions in any order they want, as many times as they want. So for example, you could enter the password first, then enter the username first, then enter the password again, maybe just change the password, and then click on the login button. And this is really important because it's exactly these paths that the designer didn't think when they were writing their stories, that the developer didn't have in their mind when they were writing the code. It's exactly those sorts of sequences that tend to find defect. It's not the sequences such as username, password, login, which is exactly what everyone was thinking. So the key point is in the model here, what we're modeling is what the user can do, not what we think the user should do. And that means we can find all sorts of paths we weren't expecting, and that's how we find defects. Another similar feature is these actions over here in the white box. So these are the global actions, either the actions that can take place at any time on any screen throughout the application. So here we have, you can go back to the Amazon home screen, you can log in, you can go to the basket, you can rotate the screen, and you can exit the app. And this is very typical. These actions tend to be the things in some sort of global menu or things tied to the device, sort of hard buttons, volume increase, volume decrease, and so on. And again, these are really important because what we're going to do is when we generate flows through the application, these global actions are going to occur at any point within that flow. And it's these kind of actions that tend to find defects because it's exactly these sorts of sequences that the developer wasn't thinking about when they wrote the application. They weren't thinking that between selecting an item and adding to the basket, you may exit the app and come back in, or you may select an item, go to the checkout, and then go back to the home screen, or rotate the screen. We've seen a huge amount of defects to do with rotating the screen at various points through the workflow. So again, generating workflows, which is not what the developer was thinking, not what the test designer was thinking, and so finding lots of defects and getting great coverage. Now there's lots of other sort of cool features of the modeling. If I go over here, you'll see there are various parameters I can set, lots of things to do with connections, variables, I can set preconditions, I can generate various values, and I can perform checks. I'm not going to go into those. We can go into those in a later tutorial. The point here is just to give you the basic idea of the modeling and to let you know there is more when you need it. So now that I have my model, let's start executing some tests. And what's going to happen here when I press the play button is Eggplant AI is going to start generating various workflows through the application. So you can see it's starting up. We're going to execute 10 tests here. And Eggplant AI, it's going to screens, it's executing actions. These actions may take us to the next screen, we pick a new action, and so on. And the basic mechanism here is very simple. Whenever we get to a screen, Eggplant AI picks one of the available actions, which is any of the actions on that screen, as long as the preconditions are met, and any of the global actions. It picks one, it executes it, does all the things associated with it, which I'll come into in a minute, maybe does the transition if it's there, and then picks the next action depending on which screen it's on. So really simple. The clever bit is how it picks which action to do next, and there's three parts to that. One part is that the tester can simply tell the model which actions are the most important. So here we have the complete purchase action. It's an important action because it involves money, it's changing database transaction values. So it has a weight of 100. Now if we compare that, and these are all relative weightings, if we go to the rotate screen, we see that the weight is only 20. Because we don't want to do that nearly as much, we're not quite so worried about it. So rotate screen is going to happen far less, we're going to get much greater coverage of that complete purchase action because the tester told us to. The next thing is if I scroll up here to the top of this log, you'll see at the top we have this loading test with IDs. When we start every test, we load all the previous executions that have occurred on this model. We know every path, every data value that was set, and so on. And we're going to use this information to make sure that we're choosing paths through the application that increase coverage. So paths we've never been down before to maximize our coverage. We're also going to look at paths we have taken before but that have failed, and we're going to do them again. Because clearly if that failed before, we want to test it again, and it's very likely that we're going to find more defects in that area. Defects tend to show strong locality. The third is the AI and the machine learning. As we're executing these tests, we're learning the patterns that tend to find defects in the application. So for example, in most applications, if you perform an action that takes you to a new screen, and then you press back and go to the previous screen, and then do that same action again, that very often causes defects. So we're looking for those patterns, and then we're replicating those patterns around different parts of the model to find lots of defects. I should mention that while we focused so far really entirely on the control flow, i.e. generating different navigations through the application, we can also model the user's data choices. And we use this data in our coverage and our deep learning algorithms. Because if you think of something like Salesforce or SAP, it's the data that triggers different behavior, not the control flow. So for example, if I go here to the select item action, I've modeled the user's decision about which of the available products it's going to select via this item index variable. So if I just bring up the definition of that. Now, I've done two things here. The first thing, as I've said, is just pick a value in the range of 1 to 20. So rather than just saying, every time pick the first product in the list or pick the second item or whatever, I've said pick one of the, pick one of the first 20 items, and then we're getting much better coverage that way. However, I've then gone and split that down into three ranges: 1 to 3, 3 to 10, 11 to 20. And these represent three different cases. 1 to 3 are the products that are visible on the screen immediately when you've done the search. 3 to 10 are the ones you have to scroll for. 11 to 20 are ones that you have to go to the next screen for. And by separating these into different groups, I've told Eggplant AI that these are different coverage points. These are different scenarios. So when I execute the test, if the first time I pick the value 2, so I've picked that one from the first set, the next time I execute, I'll pick one from one of those other ranges to maximize my coverage. We can also configure this data generation in various interesting ways. So for example, we can define if a variable is generated each time the action is executed, generated each time except the values should only ever appear once, that's generated unique, or generated the first time the action is executed, but then the same value is used on all subsequent executions, that's generated one time. So we have lots of different data generation capabilities. We're not just modeling the control flow, we're modeling the data flow as well. The final thing to explain is how this high-level model gets transformed into concrete test scripts that can actually drive the system under test and perform validations. And we experimented with many different approaches to this. We spent a lot of time on it. The most obvious approach was to start adding lots of information to the model to allow it to completely auto-generate the test script. But we found that this approach made models too complicated, impossible to relate analytics feedback to, and required a lot of maintenance. Basically, it turned the models into visual scripting, which isn't very productive or fast. So after going around this for a while, we concluded that actually the simplest approach is the best. We simply associate snippets, which are small scripts, with each action, and whenever the action is executed, we execute all the snippets associated with that action. So for example, if I go, just expand this, if I go to the My Accounts action, you'll see down here that I have two snippets associated with that action. So every time I execute go to my action in the model, we're going to go and we're going to execute these two snippets here actually on the device. Now, if I look at these snippets, I can view them here and they'll appear in the console. You can see the first one is actually just implementing the action. It's clicking on the menu icon, it's clicking on the menu item for going to the My Account screen, and then it's waiting to make sure that that screen appears. It's doing a validation and also making sure the workflow is complete. So a very simple snippet there, and actually we found that through the forced modularization that you get by taking this modeling approach, and by the fact that we're taking all the complication of the control flow, the data generation, all the different paths, we're reducing the amount of scripts people are writing by 90 to 95%. So there's a huge saving in terms of the amount of scripting people are doing. Just to show the second one, so we've got this screenshot snippet, and you can see there that that's just one line, very simple. We can disable one of the snippets, so if I'm, say, using that screenshot snippet for debug, I can just disable it, and on all future runs until I check back in, that snippet will not execute. So the key part as well of having these separate snippets is we've separated the model level from the technology level. And this gives us great flexibility in terms of algorithms, makes the models robust, and makes both the model and the snippets easy to manage. And actually, we've also found that it's by far the most efficient approach, because although there is still some manual scripting required, as I said, our experience shows that it's orders of magnitude less than you're doing today. And it means that we can keep the models very simple and not end up as visual scripting. Models tend to take a few hours to create, not days and weeks. And of course, ultimately, we're working on auto-generating those snippets entirely within Eggplant Functional, and then we'll have the best of both worlds. Now, the last thing I'd like to show is the report. So we've got three reports here along the top: run report, test case report, and coverage report. So let's just look at those quickly. The run report is your traditional report where it just lists off all test executions, whether they passed, and if I click on them, I get the full results, and I'd get these is getting summary results. If I expand that, I'll get sort of all the detailed logs coming back from the device, screenshots, and so on. So, but this is a very familiar, very standard report. If I go over here to the coverage report, we see a style of reporting we think people are going to get more and more used to when you're doing more coverage-based testing, and it's called, obviously, the coverage report. So here we see all the different screens. Let me just go to search results. We see all the different actions, and then if we go into an action, we can see all the different data elements and the different values. Remember, I showed those three different sets from the item index value earlier. And we can see which of those we've covered and which we haven't. In this case, I've been running this model a lot, and so we have 100% test coverage. But this coverage report is a great way of seeing quickly what parts of my application have I tested. We've got a heat map here, again, showing that I've tested all parts of the application. And this is very effective for having confidence in your testing. And then when you start getting test failures, it's a great way of seeing, rather than sort of going through a long list of test executions, you can just visualize which of the tests that are failing. The third report is the test case report. We find that this provides people with a great bridge between the world they're familiar with, where you have very defined test cases, and the eggplant AI analytics machine learning world, where you're working from a model and you don't have specific defined test cases that you input. You just define a model for the application as a whole and you run, and that just generates on the fly thousands, tens of thousands of test flows. But people do have still, of course, their test cases that they really care about, and we want to make that easy for people to continue the reporting in a familiar way. So what we do here is we allow people to define specifications of flows, including control flow and data flow through the application. Effectively, these are test cases, and we define them here, and when you run that report, it goes through all the executions you've done so far on this model. It tells you how many of those tests match the test case specification, and they can be partial test case specifications, so you may get lots and lots of tests matching it, and then you get the list of the specific tests that execute it, and I'll show that again. So for example here, we've said, show me all the tests which did a search and then selected an item, or all the tests that did a search by department, or all the tests that did a search and then did a search again rather than selecting an item. And you can see that, and if I click here, we'll go back over the run report, and that'll be filtered based on just the tests that match that test case. So that's the test case report. So that is the quick introduction to Eggplant AI. We hope you found it interesting. Please give it a try, send us your feedback, and we hope to hear from you soon. Thank you very much.